In this segment, we're going to continue talking about fraction equivalencies, except unlike last time where our whole stayed the same size all the time and we changed the size and the number of pieces, this time the whole is going to change its size, and we're going to talk about how that affects our fraction and the way that we write our fraction. So in the previous segment, if I started out with a 1 looking like this in my hexagon shape, and I wanted to take my 1 and cut it into two pieces, we could call it a half, my piece would therefore look like this. If, however, I wanted to cut it into more pieces, then the pieces would have to get smaller. And my diagram would look something like this. Instead of having one piece cut into two, calling it 1/2, I can now take and have more pieces, which have 6 pieces. 1, 2, 3, 4, 5, 6 pieces. I would need 3 of them. So if I have more pieces, the pieces would have to be smaller. The greens are smaller than the reds. And if I have smaller pieces, I need more of them, 3, 6. So that's what we did in the previous example. And the reason why this worked is because if we keep our whole being the same size, we have to have this trade-off between the number of pieces and the size of pieces. In this segment, I want to talk about what's going to be happening if my whole changes its size. I don't need to do that, make my size smaller, because everything is going to be larger. So the idea that we're going to be looking at in this time is if we're going to grow the outside of my 1, or my shape, to be a 1, my inside is also going to have to grow. And this is where we're going to get our proportional kind of reasoning idea, and talking about equivalent fractions as proportions. So continuing with our pattern blocks, if my whole is my yellow hexagon, my red is now my 1/2. But if I grow so that this now becomes my whole is now 2 of these, 1, 2, put together. So now my whole is twice as big as what my whole was starting off to be. So now if my whole is twice as big, then my half is also going to be twice as big. So this is going to be my half now. If my whole was yellow, my red is 1/2. If my whole was pink, then my yellow is 1/2. And it's twice as large as it was before. I can then also talk about saying, okay, I can also make it equivalent because I know my yellow is made up of 2 of these reds. And I can say, therefore, that if my pink is my whole, then 2 of the reds is the same thing as 1/2. I could say that 1 yellow is 1/2, or 2 reds is 1/2. And if the reds are 1, 2, 3, 4, if it takes 4 of those to make up my whole, I could say, therefore, that 1/2 is equivalent to 2/4. If you recall, on the very first segment I did on fractions, we talked about one of the ways is talking about us having one circle cut into 2 pieces. Or in this one we could talk about one circle being cut into 4 and shading in 2. But I could also talk about it as 2 circles cut into 4 pieces. And that's basically what I've done here. I've got 2 hexagons cut into 4 pieces. Each piece would therefore be called 1/2. And therefore we could call it 2/4 is the same thing. If I added a third piece and say I have 3 wholes and I want to cut it into 6 pieces, I might have something looking like this. I had my 3 yellow hexagons. I've cut them up into 6 different pieces, and any one of these pieces would be called this red. So there's 1, 2, 3, 4, 5, 6 of them. What do these red things, what are they called? Well, we can go back here and say that it's the exact same thing as 1/2. So again, we could say that 3/6 is equal to 2/4, which is equal to 1/2. And these would all be equivalent fractions, and they all have the same meaning, and they're all talking about the red shaped pieces that are the same size. It's just that as we grow the outside, instead of having 1 hexagon, we now have 2 hexagons, we now have 3 hexagons. As the size of our whole grows, then our size has to change as well. Using that same idea using Cuisenaire rods, if I call this my whole, then this could be called 1/2, because it takes two of these to make up one of these. So if I call the red 1 whole, then my white becomes 1/2, and there's my fraction 1/2. If, however, I double up my red, so two reds make up a pink, now if I've doubled up my reds, I have to double up the size. So two whites then is what I need, and two whites we said was the same thing as a red, so therefore I could call this fraction an equivalent fraction as well. That would also be 1 out of a possible 2 that I need. So as my whole grows, so does my inside piece, my fraction piece, my portion piece. And so I can see that if I've doubled my red into a pink, instead of being at 2 long, it's now 4 long, and now my 1/2 piece would be my red. And if I've doubled my red to make a pink, I have to double my white and to make my red. So I'm multiplying again by my magic 1 of 2 over 2. And I can show that taking my 1/2, multiplying by my magic 1 still gives me something that's equivalent. Except this time I'm not changing if I'm changing the number, I have to change the size. This time I'm changing the size of my 1, so I have to change the number. So they have to grow proportionally. I've doubled the size of my 1, so I have to double the size of my portion. So this is a little different because I'm changing the size of my outside piece, my whole 1. As opposed to keeping my 1 being the same, I have to modify the size of my pieces. Since I'm changing my 1 this time, I don't have to modify the size of my pieces, I have to modify the number of pieces that I have. So we're growing proportionally. So again, showing if I start off with my 2 and I have 3 times as many, I've left a little gap here so they don't line up quite exactly right, but if I nudged them all together, I would see that 3 reds make a dark green, and therefore it's 3 times larger. So if I make a proportional fraction for that, I have my red, 3 reds make a green, so therefore I have to have 3 times as many whites. So therefore instead of having that, I would have 1, 2, 3 whites, and 3 whites is the same as a light green, and 2 light greens make a whole. So again, if I start off with 1/2, which is my 1/2 right here, and I multiply by my magic 1 this time of 3 over 3, and there's my work there, I take my 1/2, I multiply by my magic 1 of 3 over 3, and I get 3 over 6, and 1/2 and 3/6 are equivalent fractions. Now using the other meaning, or the other way of thinking about 3/6, we could say that I have 3 holes. There's 1 hole, 2 holes, 3 holes, and I want to cut it into 6 pieces. So there's my 3 holes. I've cut it into 6 pieces. Any one of those pieces would be called 1/2. We said a white out of a red is called 1/2, so there's a white out of my red, and so any one of these 6 pieces would be called 1/2. So 3/6 could be classified as equivalent to 1/2 using this technique. 3 holes cut into 6 pieces, each piece would be called 1/2. So in this segment we talked about making equivalent fractions, except in this time, instead of keeping the whole being the same size and having to modify the number of pieces and the size of the piece, this time I'm changing the size of my whole, in which case I have to modify the number and size of the pieces, except we're growing, if our 1 is growing in size, we have to grow proportionally for the number of pieces. The size stays the same, but we're growing the number of pieces, so the overall size is going to change. So just another way of looking at equivalent fractions. And we've also looked at parts of the whole, and we've looked at if these were wholes, dividing it into a certain number of parts. So no matter which way you think of a fraction, this proportional reasoning to get an equivalent fraction also works.